In this video, an example process is described to convert 2D building footprint shapefile dataset to level of detail 1 building model of CityGML version 2 using FME. We start with adding S3 shapefile as a reader. Here, we import our 2D building footprint shapefile. This shapefile contains attributes of building IDs and height values. We can use Data Inspector to simultaneously visualize results for each transformer we add. First, we will add extruder transformer and use height attribute of shapefile to create a building block model. At this point, you can see that every building footprint geometries are now converted to a building block model in 3D. Now, to convert these building blocks to CityGML, we will add attribute creator transformer and create a new attribute CityGML underscore LOD underscore name and give it a value of LOD1 solid. The exact name of the attribute and its value is very important so that it is according to the CityGML data model of the building module. Here you can see that each building block element has a new field which is called as CityGML underscore LOD underscore name with a value of LOD1 solid. Next, we will use geometry property setter transformer and convert the attribute of CityGML underscore LOD underscore name as a geometry trait. This means that the extruded building block is now having a characteristic of LOD1 solid geometry. Next, we will add coordinate rounder transformer This transform will help us to round off all the coordinates to 2 digits after the decimal point. Now, to translate this as a CityGML building element, we will add a writer and choose CityGML as its output format. Here, we will now specify a name for our output CityGML file. Inside parameters, you can also choose the version of CityGML in which you want your output in. Here, we will keep the default one as CityGML version 2.0. Next, we will only select building element because our output should be as a CityGML building object. Now we will join the geometry property setter output port to the writer port and connect ID attribute to the CityGML underscore ID attribute of the CityGML file. Now we run the entire workflow. As you can see, a CityGML dataset is produced containing a city object member building with corresponding GML ID and a LOD1 solid geometry for each building footprint. We can also view our output in an XML editor or using a FZK viewer.